somehow another disastrous fire started in an informal settlement here in Quezon City. It's a frightening sight. Tens, hundreds of homes burned to the ground, leaving nothing but ashes and smoke, all caused by a single spark from a faulty wire. As a reporter, I've seen how these fires ignite, but what I want to uncover now is this. Beyond the flames, what invisible poisons are released into our air, and how do they silently endanger our lives? So I did some digging, and I was left with this string of information. Electrical fires are simply fires that start from faulty electrical systems like damaged wiring, overloaded circuits, and malfunctioning appliances. In the context of the Philippines, electrical faults are described as the top reason behind the biggest portion of fires each year. According to the Bureau of Fire Protection, 625 out of the 2,307 fire incidents from January to February 2005, roughly 27.9% of cases are due to electrical faults, including the misuse of electrical appliances, overloaded power outlets, and the practice of octopus connectors. Electrical fires disproportionately affect informal settlements, with some estimates suggesting that they account for the majority of residential fires and a significant portion of all fires in congested areas. In Quezon City, informal settlements accounted for 89% of all residential fires, with 71% of them being classified as severe. In 2019, 785 out of 10,034 cases were found to be caused by electrical connections, with the BFPQC stating that the majority of these incidents occur in informal settlements. Areas that are more congested have what are referred to as tinderbox slums, which are areas that are less likely to comply with fire safety standards as they possess high building density and structures made out of limited and easily combustible construction materials. Moreover, informal settlements depend on illegal and unsafe electrical connections for power, which increases the risk of overloading. It is estimated that 35% of Metro Manila's 15 million residents live in informal settlements with makeshift homes made from light materials and creative toxic byproducts in the event of electrical fires. But to get to the main point of my investigation, the byproducts themselves, I figured that I should consult the right people about it.
More technical definition of electrical fires is ignitions caused directly by electrical currents or static electricity coming from electrical faults, from poor connections, and overloaded circuits. So these would then convert potential electrical energy that possesses stored plus charged electricity into thermal energy via resistive heating. So this resistive heating creates intense heat, which causes heat and fires respectively. So basically, potential energy is stored in the electrical systems and is released, turning into kinetic energy with electrons flowing through a conductor. So upon the peak of this kinetic energy, it becomes thermal energy, which causes various materials to undergo a process called pyrolysis. So this pyrolysis, it is the thermal decomposition of materials within an oxygen-free system, followed by combustion when ignition occurs. To take the combustion of polyvinyl chloride or PVC, for instance, which is one of the most widely used synthetic plastics that provides or gives electrical insulation to different objects, to different materials, and is naturally fire resistant. So when PVC undergoes heat, it breaks down into three main materials. Oh, firstly is hydrogen chloride gas, a toxic and corrosive material. Then there's char, which is a leftover solid form of carbon, and volatile organic compounds, or VOCs, which are also harmful gases, by the way. So PVC also reacts with oxygen from the atmosphere in a combustion redox reaction. and it produces carbon dioxide, which is a well-known greenhouse gas. And then there's also water in the form of water vapor, H2O, and HCl, hydrogen chloride gas.
The next one is CO, or carbon monoxide. It's another toxic byproduct that is formed through the incomplete combustion of insulation materials found in conductors. So it is characterized as a colorless, odorless, and tasteless gas that is poorly soluble. It is highly flammable and is easily identified through a blue flame. So the lack of burning, ignition, or even molten PVC drips indicate that there is a relationship between the intensity of localized thermal faults and the insulation materials of layers, which lead to the deterioration of the insulation. So CO binds to hemoglobin more readily than oxygen, which is a main factor in reducing oxygen delivery to our tissues. So short-term effects include headaches, dizziness, nausea, confusion, and unconsciousness, with higher doses being fatal. So those exposed to CO in a long-term time frame may suffer from cognitive deficits, memory loss, and chronic fatigue due to the brain hypoxia.
Third byproduct, hydrogen cyanide or HCN, is likely formed from the combustion of nitrogen containing plastic like rubbers and fabric. It's a colorless liquid or gas with a bitter almond odor that is miscible with both water and ethanol. It is also highly volatile and reactive. Its combustion is also due to the electrical faults that's caused by the fire in the first place, as explained by the expert.
Particularly in humans, hydrogen cyanide blocks cellular respiration by inhibiting cytochrome oxidase, which is a vital enzyme that helps convert oxygen gas into two molecules of water. So hydrocyanide's short-term effects are more lethal, including a rapid onset of symptoms that include seizures, respiratory failure, and death. But long term, it may cause neurological damage, metabolic acidosis, and uh, persistent fatigue from oxygen deprivation.
And finally, volatile organic compounds or VOCs are synthetic materials that decompose during electrical fires, as seen in its melting and discoloration. It easily evaporates and is often a colorless liquid or gas that possesses distinct odors. They are organic compounds that contain carbon and hydrogen and are highly reactive in the atmosphere, contributing to smog formation. Arc and spark traces indicate thermal decomposition that eventually release VOCs into the air. VOCs are also highly flammable, formed during the breakdown of plastics and rubbers under high heat, which lead to inhalation risks. Contact with VOCs include eye, nose, and throat irritations, headaches, and nausea, which can lead into an increased risk of cancer, damage to the kidney and lungs, and central nervous systems disorders with longer exposure. Looking back now, these reading in informal settlements are often the most affected group when it comes to the electrical fires. It makes them more susceptible to the different health risks that are caused either from the immediate aftermath brought upon by proximity to the fire or being subjected to long-term effects as byproducts like VOCs makes its way into the atmosphere, contributing to air pollution. Moreover, given the financial hindrances faced by the individuals in a lower socioeconomic status, there is limited access to healthcare services to treat the short-term effects and sustain treatment from the long-term effects, adding to their already high susceptibility. Even after the fire, the effects are still there. Walls, wiring systems, and ventilation systems are already contaminated with HCl and VOCs, and these do not dissipate quickly. So the flames may be gone, but the corrosive residues remain and further damage the infrastructure, releasing secondary emissions. Acidic residues from HCl due to burnt PVC wiring corrode nails and wiring systems, weakening the already fragile structures of these tinderbox slums, making it more susceptible for the next disaster. Since these homes are made up mostly of salvage materials, it perpetuates the cycle that started the fire in the first place and does not take away any real health risks that an electrical fire poses. But moving on, there's another risk at play here to be shared by an urban planning specialist I reached out to.
As far as living goes, extended displacement is also very likely. Their homes won't be safe to stay in, so the residences would force themselves to stay in the evacuation center for longer. And since this happens, other families would crowd into these centers, which disrupts daily operations. And there is also resource diversion, as the funds that LGUs may use to continue implementing fire prevention methods are spent on cleaning up the aftermath, as burned electrical materials that produce hazardous debris that is treated as toxic waste, whose disposal and recycling methods cost more than standard cleanup. And as mentioned already, salvaging these materials after the fire poses problems with the construction of informal settlements, homes that disrupt fire prevention. And homes located here are built in a way that they share walls and roofs, so the residue of byproducts like HCl are spread across many households. So there is a need for longer cleanups, costing more for everyone involved. The residues also damage pipes and wiring systems, which also contribute to the higher cost to repair or replace the affected systems.
On an individual level, fires cause the loss of livelihoods and other important documents, making recovery a longer process. The cost of replacing everything from scratch becomes cumulative, and if important documents are lost, application processes for various forms aid to take longer. So, what can be done to prevent these byproducts from silently harming people? Firstly is to utilize education as a means of prevention. The Bureau of Fire Protection has continued to implement community-based sessions wherein they provide information regarding the most common causes of fires in the community, how to respond to smaller fires, such as demonstrating the use of fire extinguishers, and how to prevent these fires in the first place. It has also made steps towards modernizing their equipment to ensure that there are adequate supplies for firefighters to respond to causes and minimizing the risk of long-term health effects due to exposure to these various toxic byproducts. On a larger societal scale, however, there are various structural hindrances that contribute to the exposure to toxic byproducts of individuals. Firstly is the lack of sufficient and proper government housing for lower income families, which lead to the creation of informal settlements and poor living conditions. Second, there are the various legal challenges in recognizing informal settlements as a community in order to cut down on the red tape that makes applications to various forms of societal amelioration and aid more bureaucratic. Adding to that is the insufficient capacity of various social welfare programs to handle the number of lower income citizens who rely on government aid to get by, which corners them into precarious living conditions. There is also the persistent lack of uniform regulation pertaining to the usage of power connections that give the way to the infamous spaghetti wiring found across urban areas that are at higher risk of overloading, causing electrical fires. Lastly, limited access. In informal settlements in the Philippines, electrical fire byproducts don't just harm health. They corrode shared utilities, prolong displacement, and inflate recovery costs due to limited resources for repair and or replacement. Sustainable fire prevention means investing in safer materials and inclusive urban planning that anticipates both the immediate and lingering impacts of toxic emissions brought by this kind of fire. Given the various shortcomings, there are various ways to address these. Electrical fires don't just burn homes, they leave behind toxic byproducts that continue harming communities long after the flames are gone. And for families in informal settlements, these dangers are constant, silent, and really unfair. So what can we do? We start with awareness. We must learn the risks, report unsafe wiring, and most importantly, support community safety programs. Then we push for bigger change, safe housing, proper electrical regulation, and of course, stronger support systems for families who experience and shoulder greater risk. Because these invisible byproducts shouldn't decide who gets to live safely. We must remember, we protect each other by staying informed and staying united.